Calculate the weight of the cube. Remember, weight is not mass, right? So the weight of the cube is going to be the force of gravity. Force of gravity is mg, and the formula is g is f over m in the data packet, but it's buried somewhere else, right? And then the mass of it you're going to get from the density equation, right? Density is what, mass over volume, right? And then the volume of this cube is just going to be the length of the side to the third, okay? Here's your density, here's the dimension of the side. Go have at it, right? Okay. And then as far as the proportion of the volume that is above the surface of the gasoline, the God-fearing, honest way to... So when you do this, by the way, you're going to find the mass. You're going to stuff in there. Don't forget to multiply by 9.81 to get the mass. And then it says what proportion of it is above the surface of the gasoline, right? Well, the first thing you want to do, you know that this cube is going to float because it's less dense than the gasoline, right? Okay, you know that it's going to displace, I think it's like 7 newtons is the answer to this one, right? It's going to displace about 6.95 newtons of gasoline, right? So find the volume of gas, of petrol that it, wow, they use gasoline, right? Find the volume of the gasoline displaced, okay? So the question is, what volume of gasoline has a weight of about 7 newtons? And you're going to do the same calculations you did here, okay? Only kind of in a different order, right? You know that the weight is 7 newtons. You're going to figure out the volume, right? Then figure out, basically the cube is going to float having displaced that much, right? And you can figure out, I just figure out the dimensions, right? So it's going to be 0.15 times 0.15. I'm imagining that it floats with one of the square sides pointed straight up, right? Doesn't really matter, right? Times x, which is how much is down in the gasoline, right? Is going to equal that volume. Because oftentimes this is asked, like, what dimension of it is there, right? And that x is going to be about 210 divided by 720. Of 0.15. Okay, just there's a shortcut to this, right? Okay, so figure out that x, right? 0.15 minus the x is the amount exposed, right? And of course, 0.15 minus that x over 0.15 is the times 100, right? Is the percent out of the water, right? Or out of the gasoline. Okay. Easier way to do this. The amount submerged is going to be 210 divided by 720. That's the proportion submerged. 1 minus that, right? So that equals something, right? 1 minus that proportion is the amount that sticks up. Okay, and this works because let's say that the cube has 1/4 the density of the fluid, right? Then it's going to 1/4 of it will be submerged, right? If it's 1/10 the density of the fluid, then 1/10 will be submerged. If it's half the density of the fluid, half will be submerged. If it's 3/4 of the density of the fluid, then 3/4 is below the surface of the fluid, right? If it's the same density as the fluid, all of it is submerged, right? Okay, and so you can always figure out the amount submerged by just looking at the ratios of the densities. Okay, happy hunting.